11. Our team is Favyan Torres, Robert Esperon, and myself, Chris Rengifo. Our topic is Gearbox design. So a brief history on gears. Gears are considered to be one of the oldest pieces of equipment known to mankind. In 3rd century BC, Greek inventors used gears in water wheels, and clocks. Several gear types and drawings were actually found in Leonardo da Vinci's notebooks, and now CNC machines are the norm for manufacturing. So our problem statement is to design a gearbox to meet the following criteria. The horsepower to be transmitted is 5 horsepower. The input and output speed are 1600 RPMs and 80 RPMs. And the input and output direction are to be opposite. Some applications are small lawnmowers, snow blowers, and as well as some agriculture equipment.
Okay, our proposed designs, at first we had 4 gears and 3 shafts. We found out that this design did not work because it did not give us the opposite rotation that we needed for the input and output speed. Our next design required us to add an idle gear to give us that input-output opposite rotation speed. This is our gearbox animation that we came up with for our final design. There's a little animation. And here you can see we needed that idle gear right there to give us that output rotation of opposite. We have an 80 teeth and a 16 teeth gear here to give us a 5-to-1 ratio, and these 3 give us a 4-to-1 ratio to give us a 20-to-1 ratio, which is what we needed to accomplish for the input and output RPM. This right here shows us a bill of materials. You can see the exploded parts have the housing, the shafts, all the gears needed, some collars, and the bearings needed to accomplish this task. This slide shows us the factor of safety for the shafts. For our input and output shafts, our input shaft had a factor of safety of 1.8, and our output shaft went slightly below, but when we made alterations, it came up to 1.2.
Based on the calculations necessary, we had to follow the Agron procedure equations. Here we have the gear bending stress, the bending factor safety, the gear contact stress, and the wear factor safety. So right here, this is for the first contact. We're using 2 different spur gears. One is YF12 and another one is YF20. And as you can see, these are the factor safeties. We have a factor safety of above 1, and as well as our wear is above 1. Here we have contact 2. Contact 2 uses that YF20 gear along with the YF48 gear. And unfortunately, our factor safety for our first gear is 1, and it's slightly below, but that could be due to rounding errors. And now here we have the wear factor safety, where as well as we have 1 and 1.548. Here's the third contact, which is also the last contact for the output. We had a factor safety of 5.85 and a factor safety of 7.43 for a YH16 pinion and a YH80 gear, as well as our factor safety for wear will be 1.575 and 3.851. These are relatively high numbers, so we did have to do some alterations, and we came up with using a different spur gear. We used a YK12 and YK60-B, and we had a factor safety of 2.29 and a factor safety of 2.34. So this actually helped us out a lot. And our wear factor safety is above 1 as well. This actually caused our design from center to center distance to be slightly higher. So if we did have to, we had to do some alterations, conceptual alterations that can help us be able to adjust the height and have our input and output shaft completely aligned. And conclusion, it was a difficult learning process. It's not a lot of like the projects that we have gone through and learned about. It helped us select certain gears based on the specifications and criteria given to us, and it helps us, for future reference, it will help us to focus on gear selections and calculations before the design. A lot of times, probably most students would actually look at the different types of gears and start selecting based off which ones were due to the RPMs. And yeah, that is all.